The project is a remote control fire suppression robot system. The team members are Alfredo Armanta, William Galvan, Jonathan Rivera, and Andrew Mendoza.
Our team designed and developed an RC firefighting robot that utilizes 4 DC motors for locomotion, a servo motor to maneuver the hose, a water pump that is linked to the hose, and 3 flame sensors that can detect fires. Our goal is to produce a robot that can assist firefighters in extinguishing flames from a safe distance without endangering human lives by entering the flames. We aim to increase the efficiency and effectiveness of firefighting operations while minimizing risks to human life. Our robot will come equipped with flame sensors that enable it to detect and navigate through obstacles, allowing it to reach the source of the fire. Once the sensors detect a fire, the water pump will activate for a duration of 3 seconds, and the hose will spray water at the location of the fire. Additionally, the spray direction can be manually controlled to cover a 180-degree range for 3 cycles. To operate the robot, a remote control system will be utilized, featuring an IR sensor and logical conditions to enable movement in forward, backward, right, and left directions. This will allow for the precise control of the robot's movement, enabling to navigate through tight spaces and reach the location of the fire quickly and efficiently.
Our project flowchart goes as follows. We first have to set up our system by initializing all of our inputs and our outputs pertaining to their sensors. From there, we go into a continuous loop. We have 2 sensors in our case, so we have an IR receiver and a flame sensor. If a flame is detected, our system will go into an autonomous mode, which will either then be indicated by the sensor that was triggered. If our left sensor is triggered, then our nozzle will move to the left and pump will be turned on for about 3 seconds. If the middle sensor is triggered, then our nozzle will move to the middle and the pump will be turned on for 3 more seconds. Now, if our right sensor is triggered, our nozzle will move to the right and pump water out for 3 seconds. Now, if we send one of our manual control commands, the IR code will then decode the code from the remote. And if our left button was pressed, the robot will spin to the left. If our right button was pressed, then our robot will spin to the right. If our up button was pressed, then our robot will move forward. And if our down button was pressed, then the robot will move backwards. We also have 2 buttons. We have an action button, which will engage the pump and the servo, which will then act like a sprayer, going from 50 degrees to 130 degrees. And we also have a back button, which will just basically stop the robot in all of its activities in case of an emergency or something like that. And all these will go back to their loop after each of these actions have been done.
We decided to simplify things by only implementing a remote-controlled mode after thorough testing and troubleshooting. All other components of the robot are working correctly and as intended. Our team is continuously working towards enhancing the robot's capabilities, and we plan to incorporate a fully autonomous mode to enable the robot to operate autonomously in the future.
We express our gratitude to Dr. Khan for offering us his guidance and feedback throughout the semester.